It's Mr. C, and we're going to continue where we left off in 1.2. And basically, we're talking about end behavior. We're going to formalize some of our discoveries. Let's go ahead and dive in. All right, so the idea here is that basically we're going to use language to describe the odd degree power function when a is greater than 0 and when a is less than 0. So when a was greater than 0, that meant that it's going to be a positive, a negative, a positive, and a negative. So all of these are going to be written in the following format: as x approaches infinity and as x approaches negative infinity. Then the output will either point one way. The output will point one way. So I'm going to go ahead and get used to writing this. It's always going to be the similar question: as x approaches infinity to the right and as x approaches from the left, what is the output? As x approaches infinity, as x goes to the left, what is the output? I'm going to put all of these answers after these arrows. Notice how it's not quite an equation. This is just general terms to describe, hey, as x goes to the right, what happens? Okay, now I'm filling in the rest. Okay, let's go ahead and use a color to help stand out. So as for the first one, when it is a positive value, what happens is x goes to positive infinity for an odd degree function. So let's look at the odds. Well, here's an odd one, and here is an odd one. When it is a positive number, like it is here, a is equal to a positive 1. So you got to ask yourself two questions. The domain is going from, you start at the origin, the center, and as x goes to positive infinity, that means as it goes to the right, what is the line doing? Well, the line is increasing. It's going up to heaven. So it's going to be positive infinity. Next up, we got to do the same check, but to the left. What happens for my origin when I go towards negative infinity? The graph points down, going down to negative numbers, which will eventually be a negative infinity. And voila, this is my end behavior of the power function when a is a positive value. Let's keep on going. While I'm at it, I'm going to give myself a little more room to write. Okay, for the same odd power function, let's look at it when it's negative. I'm going to look at the odd one. Okay, as x approaches positive infinity, as x goes to the right towards positive infinity, notice how the graph is pointing down. The output is negative infinity. I'm going to do this again. Looking at my odd power function. As it goes towards negative infinity, notice how the graph is pointing up. That indicates it's going to continue towards positive infinity. Let's do this for even powers. I'm going to look at x squared. Ask yourself two questions. It's even. it's also a is positive 1. As x approaches positive infinity, it's pointing up. So that's going to be a positive infinity. Oop, wrong spot. Let's go ahead and look at when a is positive. What happens when I check x is a negative infinity? Notice how it's pointing up. So it's going to go to positive infinity. Let's look at when a is negative. So here, a was a negative 1. We ask ourselves the same question. What is the graph doing as x approaches positive infinity? The graph is pointing down. Negative infinity. What happens is the graph is going to negative infinity from the origin. It's pointing down. It's negative infinity. Look at when a is positive and when a is negative. Notice how they're opposites. That's exactly what a negative does. When something is negative, negative means the opposite. Now we're going to go ahead and track it for when we put the negative on the inside. So first, let's look at the original. When it's a positive number, what happens? Well, it's going to actually be the same as these graphs above. Notice here, number 1, all of the numbers on the inside are just positive, so it's not going to be really impacted. So I'm going to just copy these same rules here. So it's going to be x is a positive infinity. Here, it's going to be negative infinity. I'm looking at this. It's just the same rules for the positives. Likewise, for the evens, it's going to be the same rules. It's going to be a positive infinity. Okay, now when it's negative, we look at our new graphs. And this is it below. As x approaches infinity to the right. Again, I'm asking myself, start from the origin. Ask yourself, what happens as it goes to the right? Oh, it's pointing down. Notice what happens when it's pointing to the left. It's increasing. Likewise, if I look at an even, starting from the right, as x approaches positive infinity. Oh, positive infinity. As x approaches to the left, notice how it's positive infinity again. Notice how an even degree, the end behavior is always the same. Hence, by definition, notice here how it's always alternating. Positive, negative, positive, negative, positive, negative. Because again, these are our conclusions. I know that even degree end behaviors are always the same. And I know odd degree end behaviors are always the opposite. So you might not know any of the numbers, but again, we're just building up our ability to visualize math. Right here, this chart in C is our first steps in formalizing how to talk about visual graphs with writing. Hope this helped, team. Take a moment, write this chart down. This is a key summary of basically an odd and even power function. That's it for now.